I told you today we do a little bit of review. Alright, here's some practice. Just to kind of help jog our memories and get going here.
I mean, I'm not gonna try it out, but I don't know.
What's that?
You sitting there? Alright, friends.
What about that?
Alright, I should have here on this talking. I totally lost it. You're enthusiastic about being here. But you've got a practice sheet in front of you. You should be working on that right now. You shouldn't need my help too much with that. All right, A, what property is that? What did you write down? Hopefully you wrote something. For 1A, what did you write? Symmetric property equality. The property equality part's kind of a formality because there isn't really any other symmetric property, but we're gonna get in the habit of writing that, the symmetric property of equality. How about B? What do you think's happening in B? Associative of multiplication. C looks an awful lot like B, but it's different because what's happening in C? Commutative, yep, commutative. Think of commute, moving. Commutative of multiplication. How about D? Additive inverse, it's an inverse property. Let's stipulate which operation. So it's additive inverse. E is also an inverse, but it is multiplicative. You can abbreviate that. If you want to write out that big long word, you should say ULT, that's fine. How about F? Reflexive, the property of equality. Those two sides are identical. Do you see that? It doesn't matter that there's parentheses in them. They are identical. How about G? Transitive property equality. Transitive property equality. And what about H? Distributive. Yep. If you struggled at all, you need to spend a little more time reviewing your properties. Caitlin?
How do you know the difference between the symmetric property of equality and the commutative?
Okay. There is no commutative of equality.
Yeah.
It's commutative of an operation.
Yes.
Okay? So, the symmetric property of equality is a property of equality. Things switch around the equal sign. If they switch around a times or an add sign, then it's commutative, because those are property, the commutative is a property of operations. So they're both switching, it depends what they're switching around. You see?
Yeah, thank you.
All right, 2A. Simplify this. All right, you start in, I'll start in. We will see if we match. Anybody ask me? Will, does, good. Audra?
I got everything, but how does the number split? Like, I got like the exponent, right, put on the letters, but how did the two numbers split the fifth? The 16 things.
What do you have, 80?
Oh wait, I wrote it down.
You okay?
Yeah.
All right, anybody have a question about, 2A? All good? You can do all your stuff in whatever order you want, just be organized and make sure you get it all done. All right, go ahead and work on B, or maybe you've already started it. Let's see what you get on B.
Yeah. So I did both stuff.
I got 12 Y and 14 cover X. Leo's nodding. Are we okay with that? Okay. Given A and B, write the equation of the circle with a diameter of AB. So, here we go. Here's our circle. A is -1,4. B is 310, and we're gonna write the equation of that circle. All right, what's it take? What do I need to know to write the equation of a circle? I need to know the center, and I need to know the radius, right? So let's look at our situation here. This is a diameter. So what do we know about our center? It's the midpoint. So how do we find midpoint? Average, add and divide by 2. So -1 plus 3 is 2, divided by 2 is 1. 4 plus 10 is 14, divided by 2 is 7. So we know already that the equation of our circle looks like that. Remember, equations of circles, x minus something squared plus y minus something squared equals r squared. So now I need the radius. How am I gonna get the radius? Charlie?
Distance formula.
Distance formula, probably right here, or right here, it doesn't matter, that would be a radius. So the distance formula says, subtract our x's, subtract our y's, square together and square them together. So, did you get 313? So if the radius is indeed the square root of 13, then this number right here is going to be 13. Because in the equation of a circle, it's x squared, y squared, r squared. So, Sam, I see you kind of looking funny. Did I make an arithmetic mistake?
No, I did my math wrong.
Are you sure it was you?
Yeah.
Because it very likely to be. You good? Perfect. Solve by completing the square. Now this is a problem very much like, that isn't going to be a problem on the AP exam, I guarantee it. But on the AP exam, there will be times in the free response where you are told, do this. And if you do something else, the fact you got the right answer isn't gonna matter. You have to do it the way they expect you to do it. They want to see that skill. So here, the skill we want to see is completing the square. All right, so think about that for a second. Completing the square. All right, what do I need to do? Divide by 2. I heard someone say it. You all should be thinking it. You gotta get rid of that number if you're gonna complete the square. So the equation that I am actually going to complete the square on is this one. Okay. What do I do now?
Move the 3 over 2.
Yeah, gotta move it over, gotta make room, because we are going to turn this into something squared, right? And 3/2 does not fit now. So I gotta get rid of that 3/2 and come up with a new number that goes here. Alright? Chloe, do you remember how to find that new number that goes right there?
Take the 5x divided by 2.
Exactly. Don't use the x, just the number part. So 1/2 of 5 is 5/2. Squared is 25/4. Now what perfect, if you factor this right here, this thing you just built, if you factor that, what would be inside the parentheses? X plus 5/2. And then over here, that is going to equal 31/4. Now what? Square root. Remembering, of course, that over there I gotta make plus or minus. And that would be root 31 over 2. And then x equals -5 plus or minus. I went ahead and put them together because they have the same denominator. You can leave them as separate pieces if you like. Okay? Well, I've managed to kill your enthusiasm. This stuff's on your quiz tomorrow. All right, let's get enthusiastic again. We gotta know this. Here we go. Number 5. Find y if the slope of PQ is -7/5 and P is 3, y and Q is -8, 7. Okay. And we know the slope, also known in AP verbiage as the rate of change. That makes sense because slope is how the line moves, how its position changes. is negative 7/5. All right, how you gonna set this one up? How do you find slope? So how about y minus 7 over 3 minus negative 8? Y minus 7, 3 minus negative 8. That's the slope. But I know the slope equals negative 7/5. So y minus 7 over 11 equals negative 7/5. How do I solve that? Yep. So 5y minus 35 equals negative 77. So 5y equals, sorry, what is that, 42? I got negative 42/5, is that right? All right, 6 and 7, here we go. Do 6 and 7 with your partner, see what you come up with. I'll see what I come up with. All right, what'd you guys come up with for number 6? What equation did you come up with? Y minus 1 equals 3/7 x plus 1. And then for 7, y minus 1 equals negative 7/3 x plus 1. How does that look, everybody? Is that right? How did we get the 3/7? We took the equation they gave us, and I don't know what you did. I took the equation they gave us and got y by itself. Then I knew the coefficient on x was my slope. All right, we good with that? We good? Okay, so tomorrow we'll take a little quizzy too. When you come in tomorrow, of course, you'll put your phones up, you'll drop your stuff off, and then you will come back here. One person at each table will come back here, grab a divider out of the big box, a holder out of the little box, put it together, just like that, okay? Tomorrow's exercise will be no calculator. We didn't need a calculator for anything we just did, so we'll be okay. The table in the back is empty and this chair is empty. So if you don't want to divide her, if you'd rather not, say you're claustrophobic, if you'd rather not, you can either sit the table back there or you can sit up here. If you're by yourself, you don't need to go by All right, let's get our notes out. Let's see if we can get finished with P6. P6 will be due on Thursday. It is a very easy assignment. So you can probably, if you haven't done it already, you can probably get that done pretty quickly. All right, so we're ready, I believe, for in P6, number 3D. I think this is where we left off. Is it? Yeah. Okay. So we know how to do this. This is kind of repeat from yesterday. Newer stuff. What's going to be your first step here? Let me see. Who can I call on? Kate. What's going to be your first step, do you think, in this problem? Oh, Kate says I'm going to multiply by the conjugate. Now, is that completely okay? Yep. Do you have to do that first? No. But that's what she wants to do. It's okay. So then what, Kate? You got us into this mess. What now? By what? So these three need to be multiplied. However, multiplication is binary. That means I can only do two at a time. So I'll probably start with, I guess, the first two, and I'll multiply those together. So I'm going to get 6. Okay, that's just the first two. And what is that going to become? This is going to be plus 1. So I got 7 minus I for the first two. Then I got to multiply by Kate's 5 minus 2I. So that's going to give me 35. So what is that going to be? That numerator is going to be 33 minus 19I. Alright, help. Did I do that right? Nod or something, yeah. Good. Okay, now we might as well, we're having so much fun, we might as well do the denominator. So the denominator is going to be 25 minus 4I squared. Did you get 29 down there? Now obviously with numbers like 33, 19, and 29, you're not going to be even tempted to cancel. But remember, even if it had been 33 minus 19I over 44, you still can't cancel. If you're going to cancel, you have to be able to cancel from all 3 spots. So don't get excited. All right, is that okay? A lot of work, but not too bad. All right, let's look at number 4. Find X and Y. About this yesterday a little bit. Do you see eyes on both sides here? these are two complex numbers and they're said equal. So what did we say yesterday? If two complex numbers are equal, then what? Their real parts have to be equal and their imaginary parts have to be equal. So what is real on this side of the equation? What are the real things on this side of the equation? I'm gonna go ahead and do some distribute there, yeah. So the real parts over here are the 5 minus 7, so -2. And what are the real parts over here? X minus 3. So it looks like X has to be 1. What are the imaginary parts? Well, over here, it's -2. And over here, it's -y. So it looks like y has to be 2. That is a super simple problem, but it works really hard. Complex numbers are equal, real parts are equal, imaginary parts are equal. All right, that takes care of that. Due on Thursday or before. And we're moving on to P7, solve no calculator. Oh, this reminds me of something we need to look at too. Let's get a couple of these done, and there is something we need to look at. Now, you have your own procedure for doing this problem perhaps. We talked about this before, I hope that you're getting an understanding that absolute value of a difference is distance on the number line. So this problem literally says the distance from -3 is more than 6. So if I go 6 this way, where would I be? 3. And if I go 6 this way, where would I be? -9. Now I want that distance to be, this is where it's exactly 6. I want it to be more than 6. So I want it to be 7, 8, 9 in either direction. By the way, there's dots and color there. So my answer is -infinity to -9 and 3 to infinity. Now, you are allowed to do this problem however you want, okay? This is how I'm gonna do it because it's just easier. All right, let's look at the next one. And of course, we're always gonna, these are all inequalities, so we're gonna answer an interval notation for all of them. Okay.
Yeah, yeah.
I'm gonna go ahead and subtract that 2 over. And then this drives me crazy, so I'm gonna turn it around. And before you start yelling, which you should be at least like, whoa, 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 subtraction is not commutative, right? Unless it's an absolute value. Because if you put it in absolute value, then the order of subtraction won't matter. And so I'm gonna turn it around. You don't have to. If you're doing it a different way, it doesn't matter. You don't have to, I'm gonna turn around. And I'm gonna divide it by 2. Divide everything by 2. Now, what does it say? the distance between something and 3/2 is 3/2. So 3/2 this way would put me at 6/2, and 3/2 this way would put me at 0. I want to be more than 3/2, so again, I'm this way. So my answer is negative infinity to 0, and 3 to infinity. Let's change that sign to less than or equal. So in your notes, go ahead and change it to less than or equal. We've done enough greater than, so we'll do a less than here. So go ahead and change that, make it a less than. Did everybody do that? You're gonna get confused if you don't. Make that a less than or equal. All right, then I'm gonna times by 3. Get rid of the fraction. What does that say? On the number line, it says the distance between something and -2 is 9. So 9 this way would put me at 7, 9 this way would put me at -11. Those are shaded in this time because of the or equal to. And I want the distance to be less than 9. So I am going to shade in between, and my answer is that. Now again, if you want to split this up into 2, and remember that it's an and problem, you have to remember that. This would be an or problem, that's an and problem. And you want to do 2 different ones and put it together. I don't care. Just make sure you're getting the same answer, all right? This is the answer we want. The way you did it in algebra 2 is completely legit. All right, it's not a calculus method, so I'm using a calculus method, but the answer is. All right, problem D is different. Problem D is another inequality, but it is not absolute value. It is quadratic. Any idea what we might do to start this one, William? Then we factor it. Absolutely, we should factor it. Now, if it doesn't factor, then I will have to find my zeros using another method, like the quadratic formula or completing the square. But since this one does factor, we'll just do that. How does it factor? -4 plus 3. And then I'm going to draw my number line, and I'm going to have 2 dots on my number line. Right? And those dots will be open. And where will they be? At -3 and 4. Yes, indeed. Now I'm going to do what we call a sign chart. And sign charts are part of our curriculum, that they're very, very easy. And you may have done them before, just not called them that. A sign chart simply means pick a number in each section of the number line. So we're lucky, we only have 3 sections. So I'm going to pick a number like -4, and I'm going to plug it into my factors. And I don't care what number I get, I just want to know the sign I get. So if I put -4, this factor will be negative, and this factor will also be negative. Now remember, you're multiplying now. So a negative times a negative would give you a positive. Is positive less than 0? No, so this is bad. So now I'll pick a number in here, like 0. That is a negative times a positive, which is negative. Is that less than 0? Yep, so that's what I want. And then 5. 5 gives me a positive times a positive, which is not what I want. So my answer is simply the section of the number line from -3 to 4. Would you try problem E using the same methodology? Please use the same procedure on problem E. In our inequalities, we have to have 0 if we're doing them by hand. So you're going to want to move that number first. It does factor. It may take you another minute here to figure that out, but it does definitely factor. You get -4 and 5/2.
So you said that for the inequalities it has to be 0, right?
Yeah.
So can you not?
If you're doing it by hand.
So can you not complete the square with an inequality because?
You could complete the square with the inequality, but the purpose of that would be to find these 2 dots. When you do your sign chart, you're comparing to 0 because it's positive or negative. So you absolutely can complete the square if you, somehow you have to get these dots, okay? And they're coming from factors here, but if you have a non-factorable problem, you need to do something different. But eventually you have to get that 0 back. Because positive and negative, this is all about positive and negative, and that's a comparison to 0. Right, does that make sense?
Yeah.
Okay. All right, we good with that, guys? Everybody okay? All right, now we're moving on, letter F. And then I need to do a problem from your homework. Talk about that. So let's get letter F done. This is a cube. So what do you think we ought to do first? Take an X out. Very good, Audra. Take an X out. And then we'll look at what's left and factor that. Hopefully. Like we said, we need the dots on the number line. Those dots will come from the factors, but they will also come from other methods if we need to do them. So, x minus plus 6 and 5. So this handy dandy number line has 3 dots on it, which isn't surprising. 0, 6, and -5. Okay. Now let's figure out, put in -6, a negative, negative, negative. That doesn't work. I put in -4, and negative, negative, positive. That works. If I'm 1, I'm positive, negative, positive. That doesn't work. And if I'm 7, I'm positive across the board, and that does work. All right, double check my arithmetic there. That's what I got for my answer, but that could be wrong. Take a second. Some of you do this really fast, some of you do it more slowly. Some of you do it right, some of us do it wrong. How's that look? Does that look okay? All right with that? All right, I think I've turned back all the homeworks I had. Keep those notes out, we're gonna come back to them, but I want to do, this was from the, P3 homework. This was a problem from the P3 homework. And we were about half and half, getting it right? This was 3C in the P3. So if you got it right, great, just, I don't know, look on something. If you missed it, let's look at this and get this sorted out here. You don't have to do this, but I would suggest just multiplying by 3 so that you don't even have to worry about the fraction. So I multiply everything by 3, is that all right? Now, it is going to be impossible for me to gather all the x's in the middle. It's not going to be possible. So I'm going to go ahead and recognize that this is 2 different inequalities. It is 9x plus 15 less than or equal to 15x plus 3. And it is 15x plus 3 less than or equal to negative 7x plus 6. Does that make sense to you? Every compound inequality means that. Sometimes we don't have to split it up because we can finagle the x's around to the middle, but in this case we can't, so we are going to split it up. So I'm going to solve it. Blue would be negative 6x less than or equal to, watch my arithmetic. Did you get x greater than or equal to 2? Keep an eye on that for me. Did I do that okay? Is that right? And then my green will be 22x less than or equal to 3. X is less than or equal to 3 22s. So I saw answers that looked like this. 2 to infinity, or negative infinity to 3/27. That is wrong. Okay, this is a no. Why is that a wrong answer?
Because you can't, like, unionize positive infinity to negative.
Okay, you forgot, right, you forgot a really important word in here. When you pull that inequality apart, remember, 15x plus 3 is in between those. So it has to be greater than this, and at the same time, it is less than this. So you have to find x's that are bigger than 2 and less than 3/22. Is that possible? No. So the answer is actually no answer. There aren't any numbers that are at both ends of the number line. All right, got it? Okay. All right. Well, I have this one out. Are there any questions, any other questions about P3? Will I have it out? You have it out? We all have it out? All right, let's get our calculators out and do one of these. And then, we'll see how long that takes. We're solving with a calculator, which means we're graphing, and alright, so let's just graph that thing. Hopefully y'all know you're gonna get a parabola, right? It's an x squared is our parabolas. How are we gonna get an answer from our picture? What am I looking for, Caitlin?
You're looking for where it's above the x-axis.
Exactly, greater than 0. Bigger than 0. Where are my y values bigger than 0? Well, they're bigger than 0 from here on up and from here on up. So what do I need to do now? Charlie?
Find the intersection
I
between
need to
zero.
find those points, yeah. Now, the way I have it set up, I'm just gonna find the zeros. But if you wanna put in another equation, like a 0 in the intersection, you can. I'm just gonna find the 0. So second calc 0, here we go. .268, help me out if I'm wrong, tell me. .268. And 3.732. A couple days ago, when we did these, you wrote down x equals .268 and x equals 3.732. But this is an inequality now. So that won't be the whole answer. I want this part of the graph and this part of the graph, right? So what am I gonna write? Negative infinity to .268. Oops, I wrote close dots. Or 3.732. Is that good? All right, do B on your own, that's the last one we're gonna do. Do it with your partner, I'll do it too. Let's compare answers. Problem B. And then I will stop blabbing. This one's easier than I thought. Because what happened when you graphed it? It's all about, the whole thing is about the x-axis. So we are looking for where the curve is less than 0. Guess what? We have another empty set problem because it's never less than 0. Right. All right, well, I gave my word, so I'll stop.